This is a review lesson on operations with radicals. We're going to do adding, subtracting, multiplying, dividing. I want you guys to do the do now, which is just 1, 2, 3, and 4. Hopefully you'll see why we're doing, why we're starting off with especially 1 and 2. Pause the video if you haven't. Looking at number 1, we have 7x plus 9x. These are like terms because they have the same variable, and the variable has the same exponent. So we would just add 7x plus 9x, and what we would get would be 16x, because 7 plus 9 is 16. Number 2, we have the same variables, but number 2 has 7x squared and just plain old 9x. So these are not like terms because their variables do not have the same exponent. So this would just stay 7x squared plus 9x. Can't do anything with that. You cannot add unlike terms. In radicals is very similar rules. So if we take a look at number 3, we have the same radical, radical 2, radical 2. So these are like terms. We can add them. So that would be 16 radical 2. And look at number 4, we have radical 3 and radical 2. Those are unlike terms. You cannot add them, so this would just stay similarly to number 2, 7 radical 3 plus 9 radical 2. And when adding, subtracting radicals, we must have like terms. It's very similar to 3 and 4. So I want you guys to take 1 to 3 minutes and do A, B, C, and D. Looking at A, so the radicals are simplified as much as it could. Do we have like terms? Yes, that's radical 11 and then radical 11, same radical on the inside. There's no variables, so this is good. This would just simplify to 12 radical 11 because 10 plus 2 is 12. Looking at B, these are like terms, so we can add them. 4 plus 3 is 7, so that would be 7 rad 2. Looking at C, what's different about C? We don't have like terms, so we can't do anything there, so we 5 rad 13 plus 3 rad 7. And D, this is the one I see the most mistakes on. I see a lot of this as our answer, -8 rad 3, but that is not going to be the case. Let's take a look at what math we're doing here. So looking at D, we have rad 3 minus 8 rad 3. I agree, these are like terms. We can simplify this. But what is the coefficient really out in front of the radical 3 here? That really has a coefficient of 1. So we should really be doing 1 minus 8 to get -7. And then don't forget -7 rad 3. Yeah, make sure when there's no coefficient written out in front, there's a 1 there. So remember that. Let's go to the next page. So what if we are adding or subtracting radical expressions with unlike terms? So when I look at the first one here, 5 radical 3 and negative radical 12 or minus radical 12 are unlike terms. It looks like they're unlike terms. What we need to make sure we always do is we have to always make sure that we simplify the radical all the way. So when I look at 5 radical 3 I can't simplify anymore, so that's just going to say 5 radical 3. And then radical 12 can be simplified more. Think about the highest perfect square that goes into 12. That would be 4, so that would be radical 4 radical 3. So that would be 5 rad 3 minus radical 4 becomes a 2 radical 3. And then you'd see these are actually like terms, so we can add these together once we completely simplify that radical 12. So this would now become 3 radical 3. So you always need to make sure when you're adding and subtracting radicals that you are simplifying the radical all the way. So let's take a look at that second one. 3 radical 27 plus 2 radical 12. Let's simplify those radicals. I look at radical 27. What's the highest perfect square that goes into 27? That would be 3. So it'd be rad 3, rad 9, rad 3. Or sorry, highest perfect square would be 9, not 3. But it would be radical 9, radical 3. Then plus, well, we just did 12. That would be radical 4, radical 3. Let's simplify these. So that would be 3. Radical 9 is 3, so 3 times 3, radical 3. A lot of 3s there. Plus 2, radical 4 is 2, so times 2, radical 3. I'm going to multiply these coefficients here and here, so that would be 3 times 3 is 9, radical 3, plus 4, radical 3, and you get 13, radical 3 for our final completely simplified answer. So that's how you want to, that's how you do want to add and subtract. Unlike terms, you want to completely simplify the radicals. Sometimes when you completely simplify them, they're still unlike terms and you can't add them. You would just keep it as the two terms without adding them together. So I want you guys to do A, B, C, and D. Take your time. Take 2 to 5 minutes. These are going to take a little bit more time. And pause the video and play it when you're done. And I'll show you the answers in a second and we'll talk about them. So here are answers for A through D. Make sure you check the highest perfect square. You don't need to get the highest perfect square as long as you keep on simplifying, especially for like looking at C, that radical 36. And take a look at B. You see how B, we completely simplified both of them. So we completely simplified them all the way down to the 30 radical 3 minus 27 radical 2. But they still didn't have, they still weren't like terms, so we couldn't add them together. And yeah, that's it for adding. Now we're going to go on to multiplying and dividing. When multiplying radicals, the first, well, I guess you could do step 1 and step 2 together. So you want to multiply the coefficients and then multiply the radicands. So when I look at the first one, it's radical 5 times radical 10. I would multiply the radicands, so 5 times 10 would be radical 50. And then if it's possible, we have to continue to break up that radical. So radical 50, what's the highest perfect square that goes into 50? Well, that would be 25, so it'd be breaking down into radical 25 and radical 2. And radical 25 is 5, so that would be 5 radical 2 would be our fully simplified answer. And let's look at the next one. 2 radical 15 times 3 radical 3. We want to multiply the coefficients. So 2 times 3 would be 6. And then multiply the radicands. 15 times 3 would be radical 45. Let's see if we can simplify this any further. Is there a perfect square that goes into 45? We have 9. So this would be 6 radical 9, radical 5. Then radical 9 is 3, so it'll be 6 times 3, rad 5. This would simplify to 18 radical 5. That's all you gotta do. Multiply the coefficients, multiply the radicands, and then simplify if possible. So I want you guys to do 1, 2, 3, and 4. Take 3 to 5 minutes, take your time, pause the video, and play it once you're done. So number 1, same thing, multiply coefficients, multiply radicands. So that would be 3 times 5, which would be 15. And then the radicands, 27 times 2, would be radical 54. What's the highest perfect square that goes into 54 evenly? Well, that would be 9, so that would be 15 rad 9 rad 6. And then rad 9 is just 3, so it'll be 15 times 3 rad 6, which would be 45 rad 6. And you could, if you wanted to, you could have broken down that 27 first into rad 9 rad 3 and simplified that radical first. It doesn't matter. Sometimes it's easier to simplify first. Sometimes it's easier to simplify at the end. And you would get the same answer either way. The second one, I'm going to rewrite it as 1/2 rad 3 times 1/2 rad 3. And now I'm going to multiply the coefficients of the radicands. So 1/2 times 1/2 would be 1/4. Rad 3 times rad 3 is rad 9. And rad 9 is 3. So we 1/4 times 3, which is 3/4. And if you notice, when multiplying, if you multiply the same number inside the radical, so the same radicand by the same radicand, you're just going to get that radicand out of the radical. So rad 3 times rad 3 is just going to be 3. Much like if I were to do another example, like rad 11 times rad 11 is just going to be 11 when you simplify that. So number 3, same thing. Coefficient times coefficient, -4 times 3 would be -12. And then if you want to use the rule we just did, radical a times radical a is just going to be a. And I'll show you as a work for that. So that would be -12. If you did it the other way, a times a would be a squared. And then the square root of a squared is a. So that'd be -12a. Same thing. And 4, make sure you double distribute here. This is the most important part. We're multiplying everything on the left by everything in the right parentheses. So that would be 4 times 3, which would be 12. 4 times rad 6 would just be 4 rad 6 minus, or negative rad 6 times 3 would be minus 3 rad 6. And then negative rad 6 plus rad 6 would be minus 6. Or you could do radical 36, which you would get 6 anyways. Combine like terms. We get the 12 and the -6 to get 6. And then 4 rad 6 minus 3 rad 6, we plus radical 6. That's it for multiplying. On the next page, we're going to divide radicals. So when we are dividing radicals, we have to always make sure we have a rational denominator. We cannot have an irrational denominator. And when I look at the top 3, every single denominator here, radical 7, radical 5, and 2 radical 5, every denominator here is irrational. So we cannot have an irrational denominator. It must be rational. So what you want to do for the first one is what could I multiply radical 3 over radical 7 by to get a rational denominator? Well, what you always want to do for this is just multiply by the radical on the top and the bottom. So I'm going to multiply by radical 7 over radical 7. And watch what that does for me. So radical 7 times radical 3 on the top would be radical 21. And then radical 7 times radical 7 in the denominator would be radical 49, which when you simplify, well, radical 21 stays radical 21 because there's no perfect square that goes into 21. But radical 49 is just 7. And now we have our denominator rationalized. It is 7, and that is our answer. So you might be asking yourself 2 things. Why do we multiply by radical 7 over radical 7? There's 2 reasons for that. First off, since our denominator is radical 7, if I multiply the denominator by radical 7, I'm going to get a rational number that's just 7. Because remember, anything inside the radicand, if you multiply it by itself inside the radicand, you're just going to get that number out of the radicand. So why do I choose radical 7 over radical 7? Well, I'm going to do a little work off to the side. If I wanted to do 3 over 4 plus 2 over 8, think back to when we were adding fractions. What would I multiply 3 over 4 by to get a common denominator as 2 over 8? I'd multiply by 2 over 2, because that keeps an equivalent. It keeps an equivalent fraction, because 6 over 8 is equivalent to 3 over 4. That's what we're doing here. We're multiplying by, well, 2 over 2 is 1, so we're just multiplying. Radical 7 over radical 7 is just 1. So we're just multiplying by 1, essentially. So we're writing an equivalent fraction, but we're rationalizing the denominator for that. So for that second one, how would I rationalize this denominator? Well, I'd multiply the top and bottom by rad 5 over rad 5. And why can I do that and keep the equivalent fraction? Well, rad 5 divided by rad 5 is 1, just like 2 over 2 or rad 7 over rad 7. So when I multiply this, that would be 2 rad 5 times rad 3 would be rad 15 over 5. Can I simplify this any more? Nope. That's my answer. And let's look at the third one. So there's two ways of doing this. You could do multiplying top and bottom by 2 rad 5 over 2 rad 5 just to match the denominator. I know some people like to do that. I would not recommend doing that because it's going to just lead you to have to simplify more at the end. So what I'm just going to do is I'm just going to multiply by the irrational part, which is irrational part of the denominator, which is rad 5. So I'm going to multiply the top and bottom by rad 5. When I multiply this out, the denominator would just be 5, then rad 3 times rad 5 would be rad 15 over 2 rad 5 times rad 5 is 5. So that would equal 5 rad 15 over 10. Keep on simplifying that. You can simplify the 5 and 10. That would be rad 15 over 2. So let's take a look at this fourth one. What's a little bit different about this fourth one? We have 2 terms in the denominator, so we have 2 plus rad 5. I want you guys to take a minute, pause this video, and try to rationalize this denominator. This is what I see a lot first. I see a lot of people try and do, oh, I'm going to multiply by the irrational part of this denominator, so that would be radical 5. Watch what happens. That would be 15. Oh, sorry. Nope, that would not be 15. That would be 5 radical 15 over, make sure you multiply that radical 5 by everything in the denominator. So that would be 2 rad 5 plus rad 5 times rad 5, which would be 5. So it's not incorrect math. You can multiply the radical 5 on top and bottom if you want to. It's giving you an equivalent fraction, but it's not getting you anywhere because we still have an irrational denominator. So we do not want to multiply by rad 5 over rad 5. We're going to want to try and do something else. So whenever the denominator is 2 terms, you're adding or subtracting an irrational number, like radical 5, what you're going to want to do is you want to take the conjugate of the denominator. What the conjugate is, so say we have our denominator is like 3 plus rad 7. Our conjugate to 3 plus rad 7 would be 3 minus rad 7. So you're just taking the sign. If it's plus, it becomes a minus. And if it's, say our denominator was 3 minus rad 10, our conjugate would then be, you just change the sign, it'd be 3 plus rad 10. So we're going to want to multiply the numerator and denominator by the conjugate of our denominator, and I'll show you why after we do it. It's gonna be obvious after we do it. So the conjugate of 2 plus rad 5 would be 2 minus radical 5. Make sure you multiply it in the numerator and the denominator, or else you're not going to have an equivalent fraction, because we're really multiplying by 1 over 1. In this case, it's the same number in the numerator, same number in the denominator. So I'm going to multiply everything in the left by everything on the right. That'd be 5 radical 3 times 2 minus 5 radical 3 times radical 5 all over. You put these in parentheses if you want to. 2 times 2. Then 2 times minus 2 times radical 5 plus 2 radical 5 minus radical 5 times radical 5. So I'm multiplying everything in the left by everything on the right. Let's do the multiplication now. So that would be, numerator would be 10 radical 3 minus 5 radical 15 all over 4 minus 2 rad 5 plus 2 rad 5 minus 5. So, do you see what multiplying by the conjugate allows us to do in that denominator? Look what happens. We get a minus 2 radical 5 and a plus 2 radical 5. So the only place where irrational numbers are in the denominator are getting canceled out, because negative 2 rad 5 plus 2 rad 5 is just a 0. So that gets canceled out, and that's going to happen every single time that you multiply by the conjugate. If that doesn't happen, you either multiplied wrong or you didn't write the correct conjugate. So let's further simplify this. This would be 10 rad 3 minus 5 rad 15 over 4 minus 5 would be negative 1. And then you just never want a negative in the denominator, so we're just going to bring that to the top. So that would be negative 10 rad 3 plus 5 rad 15. It just essentially is dividing both terms in the numerator. So that'd be 10 rad 3 divided by negative 1 just becomes negative, and minus 5 rad 15 divided by negative 1, that just becomes positive. I want you guys to take 3 to 5 minutes and simplify this final radical expression. Pause the video if you haven't, and I'll show you the answers when you're done. So here's the answer. First step I did, multiply top and bottom by the conjugate. Since it's radical 3 plus 6, it'd be radical 3 minus 6. Make sure you multiply that on the top in the numerator and the denominator, so we keep an equivalent fraction. So when you multiply everything through, make sure you multiply everything on the left by everything on the right. You would get this fraction, which when after you simplify, notice because we multiply by the conjugate correctly, these middle terms should cancel. The irrational terms in the denominator should cancel, which is our goal. And then once we simplify everything, we get to here. But remember, we cannot have a negative in the denominator. So we multiply each to the top by negative 1. But also we can take out a 3, which out of each coefficient or constant. So that gives us 20 minus 7 rad 3 over 11. So that is it for this one, and we have the rest of the classwork you can finish.